Hey students, this is lesson 7.2a part 1. In the next couple lessons we're going to learn how to apply methods for solving inequalities. I'm going to just give you some examples and then I'll even give you some chances to try some on your own during this video. So I'm going to ask you to pause now and then. But in this first problem, we want to write the inequality that represents the verbal expression. Now inequalities are less than or equal to, greater than, and greater than or equal to. And the signs we use for them are, for less than, that's just an arrow like this that points to the left. Less than or equal to just has a line underneath it. Greater than is an arrow that points to the right. Greater than or equal to is an arrow that points to the right with a line under it. So for this first one, it says all real numbers x that are less than or equal to 5. So what that's saying is numbers like 4, 3, 2, 1, etc. And the way we show that is we just say x is less than, put a line under it, or equal to 5. The second part says 4 less than a number y. Well, that's this expression. Y minus 4 is greater than or equal to, is just greater than 10, not equal to 10, just greater than 10. And the greater than sign points to the right, and 10 like that. Okay, now here's where I'm going to pause, and you're going to do the next couple problems, try them, and then you can check back and see if you have the right answers. Well, I hope you have the right answer. And now I'm going to show you how to do problem 2 here. It says, is each number a solution of 3x minus 2 is less than negative 1? So basically, we're just wondering if this number here, 4, makes that true or not. And the way we're going to figure that out is, so I'll do this one down here. We're going to just substitute the 4 where the x is. So I'm going to do 3 times 4 minus 2, and just see if that's less than negative 1. 3 times 4 is 12. Minus 2, and 12 minus 2 is 10, so I just have to think, is 10 less than negative 1? That's false. So we're going to say no for that one. A is no. For B, we're going to try negative 3. I'll do that right here. So again, I'm going to substitute negative 3 in for this x right here. So I'm going to do 3 times negative 3 minus 2 and see if that's less than negative 1. And if it is, then I'm going to say, yes, that is a solution. So 3 times negative 3 is negative 9, minus 2 is negative 11, and negative 11 is less than negative 1. That's true. Since that's true, negative 3 is a solution. So negative 3 is a yes, 4 is a no for solutions. All right. Go ahead. You're going to try this problem. They guide you through it. And so pause now, try the problem, and then restart the video to check for the solution. All right. This is just some information you need to know, that when you're graphing these inequalities on a number line, a closed dot on a graph means the number is part of the solution, so the closed dot. And a closed dot looks like just is a dot with the inside filled in. An open dot on a number line means that the number is not part of the solution. And an open dot is just like that. So when you see an open dot, that means that whatever number is there is not part of the solution. And when it's a closed dot, that means it is part of the solution. So number 14, it says the endpoint of each graph is negative 3. So what they're saying is right here, that's negative 3. And we want to know, is negative 3 a solution of the inequality represented by the graph? Explain why or why not. So since it's an open dot, we're going to say no, it's not part of the solution. And the reason is because the dot is open. On this one, negative 3 is a closed dot. So we're going to say, yes, it is part of the solution, and it's because the dot is closed. All right. Go ahead, you try number 15 and see what you think. And so you should pause now, and then you can check back with your solution. All right, there's your answers. Let's go ahead and do number 3. It says, what is the graph of 4 is greater than or equal to b? 4 is greater than or equal to b. So the first thing you want to do is find 4 on the number line. And then if you see a line underneath it like we do here, that means 4 is included in the solution. So we want to use a closed dot on 4. So I'm going to put that right here, fill it in. Okay. Now you want to think of which way do the numbers make it true? On one side of this dot, the numbers will be true, the other side will be false. So like if I look at 5 here, and I think about, is 4 greater than or equal to 5? Well, that is false. So numbers over here are going to be false. And if I think about 4 is greater than or equal to this number on this side, 3, 4 is greater than or equal to 3, that is true. So all these numbers over here are going to be true. 4 is greater than all those numbers. So what I want to do then is just color in the line the way they're all true, because they're going to keep going that way true forever. All right, so that's how you'd make a graph of that. Go ahead and do problem number 3. You should pause now, try it, and then you can check back with your answers. All right, there's your answers. Now we're going to actually write inequalities here. To do that, all we need to do is look at where the dot is. So, and that's going to be part of, if it's a closed dot, that's going to be part of our solution. If it's not a closed dot, it's not going to be part of our solution. So then we're just going to choose a variable to represent all these numbers that are part of the solution. So on this one, I'll put x, and then it's going to be something with -2. And then I just have to think about, are these numbers in the solution less than -2 or greater than -2? And they're less, and since it's an open, it's a closed dot, I'm going to put less than or equal to. For b, it's an open dot, so that's going to be either less than or greater than. Since all these numbers represented by x are to the right of 1, that means they're all greater than 1. So, and since it's an open circle, we're not going to include 1. So we're not going to put greater than or equal to, we're just going to put greater than, and then number 1. All right, you go ahead and try that. You should pause now. All right, the last problem I'm going to do has to do with real life situations that can be represented by inequalities. When you go to a amusement park like Valley Fair, there's certain rides that you need, there's height restrictions. So if we look at this first problem here, it says you must be at least 4 feet tall to ride this roller coaster. Well, at least means like you should be 4 feet tall, and you could be like 4'1", 4'2", etc. Anything above 4 is okay, and including 4 is okay. So let's choose a variable. Let's choose h to represent your height. And you can be exactly 4 feet. That would be okay, because that's what at least means. 4 feet is at least 4 feet. So any number greater than or equal to 4. You should also think about this. Not all numbers greater than 4 are really solutions. Like nobody's going to be 1,000,000 feet high, but for this situation, we can just say greater than or equal to 4. Speed limit, 35 miles per hour. That means going 35 is okay. Going 34 is okay. Going 30.5 is okay. Any number less than or equal to 35 is okay. So I'm going to use r for my rate as less than or equal to 35. Well, there's some numbers less than or equal to 35 that really don't make sense, like -56. You can't go any negative speed. And in fact, you can't even go 0. You couldn't be stopped in the middle of the road. So really, r has to also be greater than 0. So what we would really say is r is greater than 0, and r has to be less than or equal to 35. to represent this. So go ahead and do the last problem here. I'll pause now. You can check back to see if you got the answers right. All right, that's it for this video lesson. We'll talk about what you learned in class the next day and try to apply some of these concepts. See you tomorrow.